The last thing we're going to talk about is how to find the area of a triangle if you're given three sides. So in geometry, when you found the area of a triangle, you were always given a height, and you did 1/2 the base times the height. But in this case, we may not be able to find the height. So if you know three sides of a triangle, you can use Heron's formula. And Heron's formula is S equals the three sides added together divided by 2. That gives you S that you're going to use into the area formula. And the area formula is the square root of S times S minus one of the sides times S minus the second side times S minus the third side. So let's try this one. On this triangle, the first thing I would do is find S. And S would be 43 plus 53 plus 72 divided by 2. So in this case, S equals 84. So now I'm going to put it into the area formula. Area equals the square root of 84 times 84 subtract 43 times 84 subtract 53 times 84 subtract 72. So I get the square root of 84 times 41 times 31 times 12. And I would punch that right into my calculator and I would get 1,131.89. It's pretty neat how this works. Heron's formula actually works for every triangle. I'm going to show you how it works by just doing one that we would know. Like let's say I had a right triangle that was a 3, 4, 5. The old way that we used to find area was 1/2 base times height. So this one would be 1/2 3 times 4. So the area would be 6, right? Because on this one, you always had to have a base and a height that were perpendicular. But if we go back and use Heron's formula, the S would be 3 plus 4 plus 5. So that'd be 12 divided by 2, which is 6. And then if I put it in the formula, I would have 6 times 6 minus 4, which is 2. 6 minus 3, which is 3. 6 minus 5, which is 1. So I get the square root of, this is 12 times 3, which is 36. And the square root of 36 is 6. So you can see how 1/2 base times height and Heron's formula would give you the same answer. But you can always use Heron's formula, even when you don't know the base and the height.